Guys, and welcome to week 8 of our lecture. For this week, we will be discussing about for loop as well as mathematical and string functions. Now, what is a for loop in Python? The for loop in Python is used to iterate or go over a sequence, usually a list, tuple, or string, or other iterable objects. This tree, list, tuple, or string will be discussed later on. So for now, think of it as just a collection of multiple numbers, strings, or characters. List, tuple, and string are those kinds. Okay? So just think of it as a collection of multiple data. So sometimes we also call them as arrays, but we will go and discuss them on a later discussion. Iterating over a sequence is also called as traversal. Okay. Syntax for the for loop. For the for loop, guys, we need to have for, and then what will be your variable, which do not need to be declared. What happens is, depending on the type of variable in your sequence, for example, your sequence or your array is a number or a string, the variable that you will declare here in your for loop will automatically take on the data type declared in your main array or list variable. Okay, I will show to you later on what I'm talking about. For now, this is the syntax. After that, followed by the colon and then the loop body. Here, val is the variable that takes the value of the item inside the sequence on each iteration. Loop continues until we reach the last item in the sequence. The body of for loop is separated from the rest of the code using indentation. Again, indentation is very important. Now, the flowchart of a for loop, okay, the flowchart is for each item in the sequence, have we reached the end? If we have reached the end, we exit the loop. If not, we execute the body of the for loop and then check again if we have reached the last item. Okay, until we reach the very end of the for loop. Take note, a for loop is fixed. It is always fixed, meaning to say it has a beginning and it has an end. Okay. For our first problem, we have create a list of numeric variables called numbers with values 6, 5, 3, 8, 4, 2, 5, 4, 11, respectively. After that, create a numeric variable called sum and initialize it to 0. Then, for every value in numbers, store it in numeric variable called val. Then add the current value of sum and val to get the value of sum. After the last value of numbers, print the value of sum. The pseudocode is for the for loop. Okay. To begin a for loop, we use for, and then for the pseudocode, we end it with and for. Always remember that this is just a pseudocode. The syntax for Python is different. Okay, but for the pseudocode, we will follow this convention. Now, numbers, numbers is equals to, take note of the bracket to denote that this is a collection of data or a list, followed by number sum. Sum is equals to 0. For each val in numbers, sum is equal to sum plus val. You can also do it as sum plus equals val. Okay, and for output sum. Now, for our program, we will declare our variable numbers together with the input. We will set sum to 0, and then for val in numbers, colon, sum is equals to sum plus val. Take note of the indentation, followed by, after doing the loop, we display the sum is sum. Okay. If you execute this program, the output is the sum is 48. Now for demonstration, okay, you can try the code that I have added in our lecture. It is under for underscore loop one dot python or dot py. Okay. Take note again, guys. Do not forget to indent. Okay? Do not forget to indent. Also, take note, print is outside our for loop. So this will be displayed only once. Okay? That is the output. For our second example, we have for every letter in Python, in the string Python, take note, single quote or double quote Python, print every letter, create a string variable list called fruits having the values single quote or double quote banana, apple, mango. For every fruit in fruits, print every fruit. Okay. This is the variable fruits, which is our list or our array. For every fruit, which means each and every value will be placed inside fruit. Okay. The end of the loop, print goodbye. Okay. For each letter in Python, I take note, this letter will take each, okay, each letter in Python. So this is a special keyword wherein it will extract each and every character from the string. Okay. And then what will happen is that it will output or print each and every letter. Now, for our fruits, we assign the value to our list fruits, and then the variable fruit will take on the value of each and every value found in fruits, and then we'll display each and every value. The end of the loop, print goodbye. Now the code is like this. So take note, we use two for loops. Do not forget the indentation. Okay, and then at the end, we print goodbye. So for the sample, we have here. Okay, if we execute it, the output is, take note, Python, banana, apple, mango, and then goodbye. Okay, so we display the value of variable letter. Okay, if you are extracting data from a string like this one, automatically each and every character will be treated as an element. So this one is almost the same or is the same as this one. Okay. So if you want to imagine how or what is happening inside the string, it's like that. So each and every individual characters are displayed. Okay. So I hope that is clear. Okay. Iterating by sequence index. An alternative way of iterating to each item is by index offset into the sequence itself. So following a simple example, we have roots again, and then for index in range, len, roots. Okay, what is happening here? Len is a method which gets the length of our list or our array. If you place the method len in our variable, it will check the length, usually how many items if it is an array or a list. So in this instance, that is 3. Okay. Whereas the range is or gives us the actual sequence to iterate over. Okay. So what's happening here is that it will start with 0. Okay, why 0 and not 1? Because in Python, the start of an index is always 0. So in this particular example, what happens here is that the range gets the upper value of our list. Okay, so the len gets the total number of elements or the length in our list, while the range gives us the topmost or what is the maximum loop or iteration that is needed to be made. Okay, if we execute this one, notice that we have a print statement and then we have fruits followed by bracket and then followed by the index. Okay, index here will return a numeric variable. So it will start from 0 and then it will end in 2. Simply because, again, reminder, the index of list or array in Python always starts at 0. So for any number of elements, that is n minus 1. So that's 3 minus 1, so that's 2. So 0 to 2. Okay? So if you are accessing values from an array, what you do is to declare the variable, the array, followed by the bracket, followed by the number, and then the closing bracket. So the value here for the first value, fruit 0 is banana, okay, and then fruit 1 is apple, then fruit 2 is mango. If you want to check the output, okay, we will run command so that you can check. But if you want to see the index, what we will do is print only the index. Okay. Banana 0, apple 1, mango is 2. Okay. Okay, the range function. We can generate a sequence of numbers using range function. Range 10 will generate numbers from 0 to 9. We can also define the start, stop, and step size as range, start, stop, step size. Step size defaults to 1 if it's not provided. Now going back to the example here that we had presented, range length of fruits. Remember, what is the length of fruits? The length of fruits is 3. Okay, so that 3, and if we use range, that will become range 3. We execute range 3, that is 0 to 2, 0, 1, 2. Okay, so that is why in this example, we were able to iterate over index 0, index 1, and index 2. Okay. We could also use range with start, the starting number, stop, the stopping number, and then the step size, which is the increment. So we can make it as 2, 3, 4, but the default is 1. Okay. The range object is lazy in a sense because it doesn't generate every number that it contains when you create it. However, it is not an iterator since it supports inlen and get item operation. This function does not store all the values in memory, so it remembers the start, stop, step size, and generates the next number on the go. To force this function to output all the items, we can use the function list. So if we want to display or output all the numbers, we could use list, okay, together with range. Now, for this example, we have print range 10. So we have range 0 to 10. If we use list with range 10, it will display 0, 1, 2, 3, up to 9. Okay, remember, sir, you told us that the index is only n minus 1. Yes, that's correct. But also remember, this one will output this one. So remember that range is lazy. It doesn't list everything. But if you want to list everything, you could use the list function. Okay, for here we have list range start is 2 and end with 8. So end 8 minus 1 is 7. We have here 2 up to 20, but step 3. So add 3. So that's 2 plus 3, 5 plus 3, 8, so on and so forth until 19. Okay. We can use range in for loops to iterate through a sequence of numbers or a string can be combined with the length function or length function to iterate through a sequence using indexing. This example is almost the same as the proofs earlier. However, we use here string. So genre is a list having strings pop, rock, and jazz. And then using for loop, we will use range, then length, genre. So that is the length is 2. So the range is 0, 2. So I in range 0, 2. So it will display I like pop 0. I like rock. That's 1. I like jazz. That's index 2. Okay. Let's check. Example. Okay. So this is the actual program. The output. Okay. For loop with else. A for loop can have an optional else block as well. The else part is executed if the items in the sequence used in for loop is exhausted or has already ended. Okay. The break keyword can be used to stop a for loop. In such cases, the else part is ignored. Hence, a for loop's else part runs if no break occurs. Okay, so this is the problem. Create a numeric list variable having digits 0, 1, 5. For every value in digits, we store it in the variable I. Print every value of I. And then if your digits have all been exhausted, print no items left. So the pseudocode is like this one. Take note, we use else. Okay, so for each I in digits, output I, else, output no items left. So this is the sample code. Okay, digits 0, 1, 5. For I in digits, print I, else, print no items left. So the output will be 0, 1, 5, and then no items left. This is 1 and then 5. Next slide. Okay, do not get confused. This is a typo error. Okay, that is for else. Okay, the output. So we have another example here for else. We create a string variable called student name with the value of so huge. Create a key value list. Now, what is a key value list? A key value list is a type of list or array wherein it comes in two pairs. Okay, usually a string or a string or a string together with a number. So in this instance, we have the name together with the value. So we have a key value list called marks with the value of James, colon 90, Jules, colon 55, and Arthur, colon 77. For every value in marks, store it in the variable student. If student is equals to student name, print the value of marks with student as index. Exit the loop. If all the value of marks have been exhausted, print no entry with that name found. Okay, so for the pseudocode, okay, it is quite long. So the pseudocode has an if statement inside. Okay, and then we have the for else loop. Okay, and then this is the declaration of the key value pair. Now take note, we have used here curly braces instead of bracket. Okay, and then to denote that we are making list with the key value pair, I use the keyword pair. Okay, just to denote that marks is a key value pair and it's not an ordinary list or array. For the program, guys, okay, we declare and then set the value for student name, and then we set the value for marks, the string, and the numeric value. For student in marks, if student is equals to student name, print marks, okay, bracket student. So student, take note, will take on the particular index. Okay. If the value is not found, we print no entry with that name found. Okay. So because our entry is so huge, when we run it, the value no entry with that name found will be displayed. Okay. Run the program, no entry with that name found. How about if I change it to joules? Okay, so we have joules here. What will happen? So that is 55. The value is 55. So mark student will what? Return the value of the numeric value here. But what if we want to uh, display the value of the name, Jules? So what should we do? Okay, in this instance, student actually is or returns the list of the key. This is the key, this is the value. So if we print student, okay, C will display Jules. Okay, so what's happening here is that it's getting, for the student, is getting all the values of the key, which is the first in the pair. That is called key. The second one is the value. So all the marks here will return the key name and then give it to student. Then we can compare it to the given student name. Okay, that is how you would use a key value pair for our for loops together with an else or for else statement. Now, what if we want to find prime numbers from numbers 10 to 20 using a for else loop? Okay. Now, in here, we will actually use a nested for loop. Okay. So, in this type of loop, we will use two for loops. This is the first for loop. Notice the range is 10 to 20. Okay. So, that is 10 to 19. Okay. For I in range 2 to the value of num. So, num here will become 2, then 10, 2, 11, 2, up until to 19. Okay. If num modulus I is equals to 0, meaning there is no remainder. J is equals to num divided by I. Print. Okay, so we have a new print system here. Notice we use percentage %D. If we use percentage %D and then that is inside either a single quote or a double quote, we will this one is more clear. If we use percentage %D, it means to say you are trying to display a number. Okay? So if you want to format your print in Python, you use percentage %D followed by the string that you want to display, and then at the end of that string, you provide the value that you want to display, okay, or variable that you want to display. Just make sure that it is properly formatted. Take note, percentage %D is used for a number. So in here we have 1, 2, 3, 3 percentage %D. So we should also have 3 numbers here, okay? So if, let us try to display this first. So I will run the code. 10 equals 2 times 5. So 10 equals 2 times 5. So that's here. Okay. Those three numbers. Also take note, we use percentage here, okay, to denote that, and then open close parenthesis to denote that the value of each and every percentage %D here will be taken from our list of variables here. Okay, and then break. Okay, if we break here in this inner for loop, automatically it will exit this for loop. Then it will go to the main loop again. It will not, take note, when we have a break inside our for loop, the else will not be executed. Okay, so in this instance, we have a break. So else here will not be executed. Okay, but in here, if we execute else, and then we found out that the number has a remainder, okay, or the modulus of that number is not equals to 0, okay, we break from the, okay, we break from the loop. So in this instance, the main loop will be broken. This one breaks the inner loop. This one breaks the main loop. So when we have gotten the value of 11 and it is a prime number, it is not, the program is not executed anymore. Okay. Now, if you take a look at the output and then compare it with our output, we ended at 11. Now, if you compare it to our output here, it's different. So why was that? Okay, so let me explain it. In here, we have our break after the else, meaning if the very first prime number that the system captures, automatically the loop will be exited. The entire loop will be exited. Now, this happened because break was indented together with print. Okay, but if I will move break and then indent it to our main loop, okay, then equals 2. Still, nothing happens. We will check. Okay. So if we try to place this break in the main loop, an error still occurs. So if we take a look back at our definition of a for else loop, it says that else executes after the entire list has been exhausted. If I use break, it exits out of the loop. So if we try to remove the break, okay, and then execute the statement, everything will now be executed. So you have to be very careful with that one. A break will not or it should not be found in the else because it's actually the last statement. It needs to be executed. It must be found in the for loop. Okay, if you want to execute a particular condition. Take note of that. Okay. Okay, now if you want to try out sample exercises for loops, you could kindly click this link at W3 Schools so that you could get your hands on how for loops work. Now, Python numbers. Number data types are numeric values. They are immutable data type, meaning that changing the value of a number data type results in a newly allocated object. Number objects are created when you assign a value to them. For example, we have var1 is equals to 1, var2 is equals to 10. You can also delete the reference to a number object by using the del statement. So the syntax of the del statement is delete or del, then the name of the variable. So del var1, comma var2. You can delete a single or multiple objects using the del statement. Del var, then del var underscore a, comma underscore b. Python supports four different numerical types. The int are signed integers. They are positive or negative whole numbers with no decimal point. We have the long integers, also called longs. They're written like integers and followed by an uppercase or a lowercase letter L. We have the float or floating point real numbers. They represent real numbers written with the decimal point dividing the integer and the fractional parts. They may also be written in scientific notation with an E, capital or small, indicating the power of 10. For example, 2.5 E2 is equal to 2.5 times 10 raised to the power of 2, which is 202. Then lastly, we have the complex or complex numbers are a form of A plus B or A and B floats are floats and J or J represents the square root of negative 1. So A plus B, J, A, which is an imaginary number. The real part of the number is A and the imaginary part is B. Complex numbers are not used much in Python programming. So we have here the samples of int, long, and float. Python allows you to use a lowercase l with long, but it's recommended that you use only an uppercase L to avoid confusion with the number 1. Python displays long integers with an uppercase L. A complex number consists of an ordered pair of real floating point numbers denoted by A plus B and J, where A is real part and B is the imaginary part. Okay. We could also convert different number. We can also convert a data type to a number. So we have the different number type conversions here. For example, usually it is used for string or if we want to convert if we want to convert a number to another type of number, we use the number type conversion, not string, guys. I'm sorry for that. Int x converts x to a plain integer. Long x converts long. Float x converts x to a float. And complex x converts x to complex. Now, take note, guys, x should also be a number data type. Okay? Built-in functions in Python. Python offers nearly 60 built-in functions and methods to make developers' life easy. You can see below mostly used Python built-in methods with examples. So these are the built-in methods. First is the absolute or ABS, open close parentheses. Take note, functions are commands that are used in programming languages. Usually, you enclose your variable inside the open close parentheses. Okay, and then the name of the function is the very first one that you should type, followed by the open close parentheses. So in Python, we have the absolute or abs function, which returns the absolute or positive value of a numerical value. For example, we have x is equals to absolute negative 7.25, print x, the output is 7.5. We also have float, which transforms a numerical value to float. A is equals to float 5. So when we print A, the value is 5.0. We also have format, which transforms the defined value into a specified format. For example, A is equals to format 1.5 comma, single quote, percentage, single quote. When we print it, it will display 150.000 something percent. We also have the hex or the hexadecimal, which returns the hexadecimal value of a number. For example, A is equals to hex 225. The output is 0xe1. Okay. We also have the input function, which accepts input from the user. Okay. So for example, I think we have already used input before in our previous samples. We have print what is your name, A is equals to input. So it will ask for the user input and then display hi, okay, hi, plus. Take note, when we are using plus to a string and then to another string, what we are doing is concatenation or connecting these two strings. We also have int, which converts a value into an integer value. So we have int 2.9 and then we print it, the output is 2. We have also the length or len, which returns the total number of elements in a particular object or list. So in this one, print len A, the answer is 4 because we have 4 elements. Okay, so these are just samples of some of the functions that we have discussed. We have the absolute, and then we have float, we have hex, and then for the input, I. Let's try if this one will work. We try to input a value and then they do. Just making sure that the input is a number. Let's see if it this one will work because if I'm not mistaken, input is string. Please share name, Mel, then input again number, let's say 25. Load 25. So it's working. It thought it will not work. So you can accept input. Just make sure that that is numeric if you are performing a numeric function. You can do all the other functions if you want, but I will not go back to them one by one. You can try them on your own terminal. Python math functions and how to use them. Python math is a built-in standard module used to work with complex scientific calculation. If we want to evaluate something like trigonometric functions, logarithm, etc., they are under the math module. So we use the Python math functions. The most used Python math functions are the F absolute, we have the C or ceiling, we have the floor, factorial, and GCD or greatest common divisor of two numbers. Python math functions. In order for us to make use of the math module in the Python application, we need to import the module using the command import math. Take note guys, if you will not do this on the before you perform the math operations, it will have an error because this import command actually imports the math library into our program. It is not loaded by default because Python will not load it because it doesn't know if you need to use it. So in order for us to use it, we need to do import math. Note of that. The math module does not support complex data type. If you want to use complex data type, you use the C math module. But for our discussion, we will just be using the math module. Okay. So first example is import math. Data is equals to 21.6. Print the floor of 21.6 is okay, comma, math dot floor, open close parenthesis data. So the answer is the floor of 21.6 is 21. So floor, if you are not familiar with floor, it gets the lowest value of a particular number. So if it has decimal places, all it does is to remove the decimal place and that will be the answer. Whereas if you are using C or ceiling, it is the reverse. It gets the upper value. As long as it has a decimal value, it will automatically round up. So floor is round down, ceiling is round up. Okay, we can also display the value of pi or using mat.pi. Okay, and this will be the output. We can also use it to find the power of a particular number using pow, close parenthesis xyz, where x is the base, y is the exponent, and z is the optional modulus. Okay, ceiling, as I have said, it gets the upper part or round ups the number. It has a decimal place. Okay. You could actually also use the absolute value in math using that fabs. However, absolute value cannot be used without the word f or fabs. If you just use math.abs, you will encounter an error because abs is already a reserved keyword which I have used earlier for the built-in function. Okay. You could also make use of the exp and log functions. Okay. The log function is used to get the log value. So for example, here we have number 1 e dash 4 to print the given number x is number, print e exponent x, format that exponent number minus 1, then log fabs x base, mat.log mat then fab number 10. So the output is this one. Let's try do that. So these are some of the functions that we have discussed. We will try to run said functions. 8, 1.9. So usually, you just need to get the particular line where the error happened. In this instance, I think there's an extra space here. That's why there was an error. Okay. So this is the floor. So this is the ceiling. Sorry, this floor, then ceiling. Okay, and the value of pi. And then this is what? Power, 2 raised to 3, 8. Take floor value, 22. Take note why was it 22? Because we round, floor is round down. So negative 21 and negative 22. Negative 22 is the lower or the floor of negative 21.18. Ceiling is negative 21. Observed value is 21.18. The given number x is exponent and then logarithm. Okay. You can actually use or make a scientific calculator using the built-in functions of Python. Okay, we can also do trigonometric functions. All the trigonometric functions are available in Python math module. So you can easily calculate sine, cosine, tangent, uh, e cos, e sine, e tangent, etc. You can also convert angles from degree to region and region to degree. This is the sample that we have. So let's try to run it. We run it, we will get this particular sample wherein we are getting sine, cosine, and tangent using the angle. Let's make a new screen. Okay, let's try to run. Import math again. Simply because if we are doing a copy paste, sometimes there's a space left. Okay, invent character in identifier, math regions. Take note, even the space is very, very critical. Okay, so this is the answer. So we have here all the Python math functions table. You could try to use it, try to experiment, and see how they work. Okay, I will not go through them one by one, so because there are many. Next are random number functions. They are used for game simulation, testing security, and privacy applications. The most commonly used are we have choice, followed by the sequence or what particular number that you want to get the choice from. It is a random item from a list, tuple, or string. We have rand range or random range. We have start and stop, step, a randomly selected element from a range. We also have a random float, random float r such that 0 is less than or equal to r and r is less than 1. We also have the seed, which sets the integer starting value using generating random numbers. Okay. We also have the shuffle, randomizes the items of a list in place, and uniform, a random float, r such as that x is less than or equal to r and r is less than y. Python random module. It is a built-in module to generate the pseudo-random variables. Can be used to perform some action randomly, such as to get a random number, selecting a random element from a list, or shuffling elements randomly. So these are the sample commands. Take note, just like the math functions, we need to import the random library. So, for example, we have import random, print random, that random. Now, the output will not always be this one. Guys, take note, this is random. This is generated by the computer. It is not always this. Okay, take note. Because sometimes you might run this one and then you might get curious why the output is different. Take note, this is random. Okay. We also can generate random integer using randint. Okay. We have the starting and in the ending integer value. So in this example, we outputted 49. Then the rand range can display random values using a range. And then we can use the choice, import random choice. And the output is this one. If you use a string, it will randomize each and every character and then just select one. If you use a number, it will just input or display one particular number. The shuffle is used to rearrange our list. So take note the numbers are 12, 23, 45, 67, 65, and 43. Using shuffle, we could rearrange the order of the numbers. Okay. Okay. So these are some of the samples from the lectures that we have discussed for random functions. Okay, print numbers. I just copy pasted it. That's why we are getting some space errors. Random dot choice. Okay. Okay. So these are the sample output. So take note when you try to copy and paste the code, just double check on the spaces, okay, so that you could avoid the error. Okay, lastly, guys, we have Python strings. Strings are amongst the most popular types in Python. You can create them simply by enclosing characters in quotes. Python treats single quotes the same as double quotes. Creating string is as simple as assigning a value to a variable. For example, var is equals to single quote hello world, var2 is equals to double quote Python program. Accessing values in string. Python does not support a character type. These are treated as strings of length 1. Those also considered a substring. So take note, we do not have a character data type, only string. So if you are to declare single quote H, single quote, okay, it's the same as declaring a string. Okay, so take note of that. We only support string. To access substring or part of a string, use the square brackets for slicing along with the index or indices to obtain your substring. So for example, given the two variables, we want to get the first index of bar 1, which is h, and then for bar 2, this is called the slice. So start with index 1 until the fifth index. So 0, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. Up until the fifth index. Okay, 0, 1, 2, 3, 4, 5. I think okay, let us double check on that later on. So for the first example, we have H. Then the second example, we have Y, T, H, O. Okay, so I'll double check on this one. Okay, so this is the correct answer. For slice, what happens is that this is the index, and then this will be your this will be treated as the count or up until what character. Okay, so index starts with 0, so that's 0 base, and then this one is 5, but it ends with O, simply because index is 1, and then we will stop at the fifth character. So 1, 2, 3, 4, 5. The fifth character is O. So starts with Y and ends in O. Slice 1, index 0, index 1, and ending in the fifth character. So the output is YTHO. Okay. Updating string. You can update an existing string by reassigning a variable to another string. The new value can be related to its previous value or to a completely different string altogether. So for example, guys, we have var1 is equals to hello world, print updated string, var1, okay, colon 6, okay, When the above code is executed, it produces the following result. Updated string, hello Python. So what happens here is that we are getting what? 1, 2, 3, 4, 5, 6. So hello space is the sixth character. And then here, we could also write this one as 0:6. Okay, so as not to confuse you, because we use blanks and the default is 0. It starts from index 0, so that's H. 1, 2, 3, 4, 5, 6 up until space, hello space. Concatenation plus Python, so it becomes hello Python. We also have special operators for string. So for example, given A is hello and B is Python, we have plus, which is for concatenation, and then asterisk, which is for repetition, bracket, which is for slice, and then range slice using colon. So the first one is the index, and then the second number is for the how many or what particular number or what particular part of the string will it end. We also have in, which returns true if the character exists in the string, and not in, which is the reverse of in. We also have what we call slash. We also have what we call R or capital R, which is called the raw string. It suppresses the actual meaning of escape characters. So through R or capital R, we are able to display special characters like backslash n. Take note, backslash n in programming pertains to new line. Okay, if you use backslash n, the print display will be printed on a new line. We also have percentage, which we have uh, used earlier to display or format special variables, particularly to use it to display numbers, decimal places. Okay. An example is this string formatting operator. For example, this operator is unique to strings and makes up the pack of having functions from C string F. Okay. So print my name is percentage %s, which will display a string, and weight is percentage %d. As I have said, that is a number, particularly integer. So through the use of this one, and then open close parenthesis, percentage open close parenthesis, we are able to replace the value of percentage %s with Sarah and percentage %d with 21. When the above code is executed, it produces the following result. My name is Sarah and weight is 21 kilos. So these are the other symbols you could use. Percentage C, character, percentage S is string, I is decimal, D is signed decimal. Okay, so percentage I and D are the same. Percentage U, O, X, capital X, E, F, and G. Okay, we could also use triple quotes that allows us to span multiple lines, including verbatim new lines, tabs, or special characters. When the above code is executed, it produces the following result. Note, however, every single character has been converted to its printed form right down to the last new line at the end of the string between the up and closing triple quotes. Okay, so the output is this one. Okay, this is a long string made up of several lines and unprintable characters such as tab, and they will show up that way when displayed. So we even have backslash t, okay, and backslash n. Okay, if we will just display this one using double quote, they will not be displayed. Okay, So what we did is to use double quote in order for us to state to our Python that we want to display it as it is. Okay. We could also display raw string. So for example, in Python, if you do this one, print single quote C colon double backslash nowhere, the result will be C colon backslash nowhere. Now, in order for you to display the string as it is, you could use either small r or capital R followed by the expression. So once you execute it, you can display the double backslash at it, as it is. Okay, these are the different string functions or methods that we can also use. We have capitalize, which capitalize just the string or the variable. We have center, which we can use in order for us to pad a string left and right. We also have count, which counts how many times a string occurs. And then there are other stuff here. We can also check if a string is numeric, if string contains only spaces, if it is upper, the length of the string, can display the lowercase of the string, okay, the maximum and minimum alphabetical character from the string. Okay. You can try this one as we will not use everything. Okay, I just displayed it to you. So for the string functions, I have here a sample where you can find some of the functions. We have capitalize, we have center, we have find, okay, we have isdigit, we have the triple quotes. Okay, so let us run the samples. This will be the last sample for this lecture. Take note. The asterisk for the string repeats the particular variable or string. How many times? So twice. So hello, hello. Slice, index, and then in H is a backslash n. Okay. So those are the samples that we have for our string functions. This will be the last topic for our midterms. Everything discussed here will be included in your third quiz as well as in your fourth quiz if ever we are to create a second removal exam. That's it. Thank you. And for any questions, kindly drop me a message on our Discord chat.